Welcome back, chemistry fans. Today, what we're going to do is our acid nomenclature homework. I believe this is unit 5, topic 6. So let's jump right into it here. Boom. Okay, so we have learned that there are 3 different ways in which we can name acids. Now, the first of these is a binary acid. By and large, you'd probably be safe if you guessed that all acids end with ic. But with the binary, we do something which is not a part of the normal role. We add a prefix. And I know prefixes were exclusively saved for the covalence before, but now we've got a prefix that we must add for these binary acids. So we first must recognize that this is binary, meaning that there are only 2 elements. It's not the polyatomic that you see below it with parentheses and more than 2 elements. So the name of this bad boy is going to end up being the prefix hydro, and then we're going to put phos, for, and the suffix is going to be ic. So it's unique in that it was not phosphorus or phosphide, it's phosphoric, and I know that that's a similar pattern to when we had a polyatomic ion that was called phosphate, but this is different. So we just got so many suffixes that we have to get separated. But for the binary acids, we're going to put a prefix of hydro and a suffix of ic. Now, balancing this, we must know the charges. I must look on a periodic table to figure out what the charges are. So I will pull up a periodic table so that we can see where these charges are coming from. Hydrogen is in the first column, so it has this charge of +1. Phosphorus is way over here on the far right side, and it's got a charge of -3. So now that I have those 2 charges available to us, we are going to utilize them to put the charges in the air like you just don't care. We are going to crisscross them down, and it balances out with an H3P. Now, on the second one, the charges are actually identical. It's rare that this would happen, but it is the case for this one. Phosphate has a charge of -3. The one below it, phosphite, has a charge of also -3. So this is a rare instance where all of the polyatomics and the element, they all agree with the same charge. But that, I guess, could help you to memorize it if you ever get to that point. So balancing these charges, again, requires a crisscross applesauce. So they're all going to look very similar. H3PO4, H3PO3, but the name is going to change. So with this acid, we have a phosphate, and it just becomes phosphoric. It has no prefix at the end. It just ends with this ic. And that's why I say you'd be safe, because the majority of the acids end with ic. The binaries have hydro as a prefix. The polyatomics do not. Now, because the next one has a similar name, it has to take, and here's where it gets weird, because its name was phosphorus, and it becomes phosphorus acid. So it's just an emphasis on the syllable as to how its name goes. So it is hydrophosphoric, phosphoric, and phosphorus acid. All right, now, next one, we've got all these nitrogens. So this one, it gives you the name of hydronitric. Well, that means it is binary. When it has the hydro in front, the charge of nitrogen is -3, the charge of hydrogen is +1. We crisscross applesauce those charges, and the final answer is H3N. For nitric acid versus nitrous acid, it's HNO3 and HNO2. The charge on nitrate and nitrite are -1. The charge on the hydrogen is +1. Therefore, they've already canceled out, and the formulas just end up being what they are written out as. Thank you very much. Hopefully, it's getting there. You're going to have to practice. There's a lot of good information here. Take care. See you soon. Bye.